Okay, so we will start our chapter. Sorry, not chapter, the question paper. And in yesterday's class, we have completed till question number 20. So now we will go ahead and solve the next questions. Okay, then. So our next question is question number 29. Now we have started. Just a minute. Now we have started this short answer type question and it is of 2 marks. So next question is, first is, show that the momentum of a particle will remain, just a minute. Okay. Will remain unchanged if the force acting on the particle is 0, and there is or option. And next is, explain why does a cricket player lowers his hands while catching a ball safely. So there are 2 questions in our, so we will solve this and write the solution for it. So first question is, show that the momentum of a particle will remain unchanged if the force acting on the particle is 0. So there is net force 0 and we have to prove that momentum will be conserved. So according to Newton's second law, the force acting on a particle is equal to the rate of change of momentum. So we'll write that a formula for force and then we will go ahead and prove that. So let's start. So we can write according to Newton's second law of motion, the force acting on a particle is equal to the rate of change of momentum. F is equals to dp upon dt. So this is the formula for force, where F is force acting on the particle and P is momentum of the particle. So if the force, just a minute. So if the force acting on the particle is 0, then F is equals to 0. So dP by dt is equals to 0. And this means the rate of change of momentum is 0. Therefore, momentum does not change with time. So it implies that P is constant. So this is the answer for this. Now the second question was, explain why does a cricket player lowers his hands while catching a ball safely. So why this happens? So when a player catches a fast moving ball, its momentum must be reduced to 0. So to decrease the momentum, this person will take his hand little bit behind. Okay, so we can write, or when a player catches a fast moving ball, its momentum must be reduced to 0 according to the impulse momentum theorem. So it is force into time is equals to change in momentum, where F is force applied, T is time of contact, and delta P is change in momentum. Since the change in momentum is fixed, increasing the time of stopping will reduce the force. So when the player lowers his hands while catching, the time taken to stop the ball increases. So therefore the force acting on the hands decreases. Hence, the player lowers his hands to reduce the impact force and catch the ball safely. So this is how you have to write the answer for this question. Now we will go ahead and solve next. So next question is, why is it dangerous to stand near the edge of a railway platform when a fast train is crossing it? So why is it dangerous to stand near the edge of the railway platform when a fast train is crossing it? So a fast train produces low pressure region due to the high velocity air, and according to Bernoulli's principle, people may be pulled out towards train. So that's why they suggest that don't stand near the train. So a fast train produces low pressure region due to high velocity high velocity of air. According to Bernoulli's principle, people may be pulled towards the train. Therefore, standing near the edge is dangerous. Now, just a minute before the next question. Okay, so next question is question number 31, and it is, if the door of a working refrigerator is kept open for a long time in a closed room will it warm or cool the room? Explain. So I have written the question, but if you have seen the previous lecture of sample question paper solving lectures, so this question appear in that SQP also. So first thing is, since this question appeared 2 times, so remember it is important, it can appear in your exam also. And second is, I am not solving and writing answer in this again. You have to watch that previous lecture of sample question paper, because I have already solved this question and write the explanation. So go, if you have not watched it yet, go and watch that lecture. You can see the answers properly. And since I have mentioned that it appears 2 times, so think that it is important. Okay, so we will go ahead and solve the next question. Next is state the factors on which the speed of a wave traveling along an ideal stretched string depends. So it is asking for the factors on which the speed of wave traveling depends. So we will find out that. So as we know the formula for the speed, so first of all write that speed of wave on stretched string. So formula is V is equals to root under T upon mu. So V is equals to root under T upon mu. It means it depends on T and mu. And what is T and mu? T is tension and mu is mass per unit length. So this velocity depends on tension and mass per unit length, as you can see. So just write it. Thus speed depends on tension and mass per unit length, or we can also call it linear density. Mass per unit length is linear density. So this is the answer. Now next question is, just write that. All harmonics are overtones, but all overtones are not harmonic. How? So we have to write why all harmonics are overtones but not all overtones are harmonics. So as we know that all harmonics are overtones but not all overtones are harmonics. Why? Because frequencies of closed pipe is F or 3F or 5F. So 3F is the first overtone and 5F is the second overtone, but not the harmonic. Okay, just write it. So for closed pipe, frequencies. It is F, 3F, 5F and so on. And here 3F is the first overtone, and it is also harmonic. And 5F is the second overtone, but it is not harmonic. Multiple of 2, so that's why. Now next question is, so we have the question from logic gate, and it is y a b y dash. So it is asking for name the logic gate shown in the diagram and complete the truth table given below. So this is the truth table: a b y dash y, 0 0 0 1 1 0 1 1. So this is the truth table. So we have to complete it and name the logic gate. So from diagram, as we can see, this is AND gate and it is followed by NOT gate. So therefore it is a NAND gate. So we can write the diagram shows AND gate followed by NOT gate. Therefore it is a NAND gate. And we have to find out the truth table. So just I am filling here only, just change the color so that you can see the difference. So it is 0 0 and of 0 0 is 0, and it is NAND, so it is 1 0 1, it is 0 and 1 when we take the NOT. And of 1 0 is 0 and NOT of this is 1, and of 1 1 is 1 and NOT of this is 0. So this is the truth table. Now the next question, and it is using dimensional analysis verify Stokes' law, or a spherical body of radius r and density sigma, no, density rho, density rho is dropped into a viscous fluid of viscosity eta and density sigma. Obtain the expression for its terminal velocity. So this is the question. First we will solve the first question, then second one. And also from here the 3 marks question is started. So the first thing, just dimensional analysis. Using dimensional analysis, verify Stokes law. So first of all we will write what Stokes law is, and then we will solve it. So we can also start directly because it is not asking for the statement, but I am just telling you. So Stokes law states that viscous force acting on a small spherical body moving through a viscous fluid is directly just a minute. Okay, yeah, directly okay. So Stokes law states that the viscous force acting on a small spherical body moving through a viscous fluid is directly proportional to the radius of a sphere and velocity of a sphere and the coefficient of viscosity of the fluid. So we will find out the formula for this from the dimensional analysis, right? It is asking about dimensional analysis. So the formula is F is equals to 6 pi eta RV, where F is viscous drag force and eta is coefficient of viscosity and R is radius of the sphere. And V is velocity of the sphere. Now we have to prove from the dimensional formula. So let the viscous force F, let the viscous force F depend on coefficient of viscosity eta, radius of sphere R, velocity of sphere V. So F is directly proportional to eta to the power A and R to the power V and V to the power C. Anywhere if they ask you to give the dimensional analysis, then you have to write like this, that what it depends on, and give power ABC some variable, and then you will find out that what is the power. Now we will remove the proportionality and keep a constant eta a r to the power b and v to the power c, and here k is constant. Now we will write the dimension. So dimension of f is mlt to the power minus 2, and dimension of eta is ml to the power minus 1 t to the power minus 1, and dimension of r is l, and dimension of v is l t to the power minus 1. So these are the dimension of the given, and now we will substitute. So by substituting dimensions, so it is mlt minus 2 is equals to ml minus 1 t minus 1 to the power a l to the power b and lt minus 1 to the power c, and it comes out to, just keep m one side, l one side, and all the things. So m only a, for l there is minus a, b and c, so it will be minus a plus b plus c, and for t it is minus a and minus c, so it is minus a minus c. Now we will compare both sides. So by comparison, as you can see, a is equals to 1. So by comparison, a is equals to 1, and here l is 1 and this, so we can write minus a plus b plus c is equals to 1, and second is minus a minus c is equals to minus 2. So here we know the value of a, put a here, minus c is equals to minus 2, keep c one side and numbers one side, so we will get minus 1 plus 2 is equals to c, so c is equals to 1. So this is value of c, and here it is value of 1. And now put all the things in this to find b. So minus a plus b plus c is equals to 1, and it is also 1, a is 1, and we have to find out b, and c is 1 is equals to 1. So this minus 1 and this 1 get cancel out, and we get b as 1. So our formula will come out as f is equals to k, and power of all is 1, so eta rb, so b is equals to 1. So f is k eta rb. This is the derivation. So that's how you calculate. Now we will solve the second part. Where is the so here is the spherical body of radius r and density rho is dropped into a viscous fluid, and viscosity eta and density sigma. So obtain the expression for its terminal velocity. So we will write for this. So first of all, what is terminal velocity? Okay, so terminal velocity is when a small spherical body falls through a viscous liquid, its velocity gradually increases, and after some time the viscous force and upthrust balance the weight of the body. So at this point the net force of the body will become 0, and body continues to move with a constant velocity, and this constant velocity is terminal velocity. So write that when a small spherical body falls through a viscous liquid, its velocity gradually increases. After some time, the viscous force and upthrust balance the weight of the body. At this stage, the net force on the body becomes 0. So the body continues to move with a constant velocity. This constant velocity is called terminal velocity. So terminal velocity is the maximum constant velocity attained by a body falling through a viscous fluid, and condition at terminal velocity, weight is equals to upthrust plus viscous force. Thus, the acceleration becomes 0 and the body moves with uniform velocity. So this is the answer. Now we will go ahead to the next question. And just a minute. Okay. Okay, since so from here we have covered till question related to these topics, and now we'll solve the question related to semiconductor devices. Okay, so the first question is, do we solve this? Let me check once. Did we already solved it or not? (19, 20, 29). Okay, we have missed in between question, so let's cover it now. So the question here is, it is the fill in the blanks and it is of 2 marks, and the question is 27 and it is fill in the blanks. A is resistance of a semiconductor blank with the increase in temperature, and B is the number density of holes and number density of free electrons are equal in semiconductor. So yeah, so first question is, let's change the color so that you can see clearly. Resistance of a semiconductor with increase in temperature. So what happens with the resistance of semiconductor if we increase the temperature? So resistance will decrease. If we increase the temperature, resistance will decrease. And second is the number density of holes and number, here is the blank, this is the man. So the number density of holes and number density of free electrons are equal in semiconductors. So number of electrons and number of holes are equal in intrinsic semiconductor. So we fill here intrinsic. Now next question is 28. Again fill in the blanks. Fill in the blanks. So A is blank is especially doped PN junction diode which works in breakdown region, and B is the width of depletion layer of a PN junction when it is reverse biased. So first is especially doped PN junction diode which works in breakdown region. So about which it is talking about? So it is talking about Zener diode. So we will write Zener diode. Second is the width of depletion layer of a PN junction when it is in reverse bias. So what is the width here, or what happens to the width? So it will increase. So we will write increases. This is the question. And next question is question 41. So here 2 and this question is of 3 marks. Semiconducting materials X and Y are made by doping just a minute. Okay, by doping germanium crystal with indium and arsenic respectively, the two are joined end to end to form a junction and connected to a variable battery as shown below. So this is the figure, and now answer the questions given below. A is name the type of semi-conducting materials X and Y. B is the junction forward biased or reverse biased. C is sketch VI graph for this arrangement. So here is 3 parts and it is of 3 marks, so we can take it as 1 mark for each. So first of all, it is asking for the type of semiconducting material. So we will write for A, and type of semiconductor is type of semiconductor. For first X, it is P type because of indium doping, and second is Y and it is of N type. In this there is arsenic doping. Now second question is the junction forward biased or reversed biased? So this is forward biased, so the arrangement shows it is forward bias. And C, it is asking for a sketch VI graph for this arrangement. So we will it is asking to sketch, yeah, so we have to sketch that. So we have to sketch the diagram in this, and it is like so this is V, voltage, and this is current, and graph will look like something like this. It is a small reverse current. So this is the graph. In this you can write about this, that the VI characteristic curve shows the relationship between voltage V across the diode and current I through it, and in forward bias current increases slowly at first and then rises rapidly after the cut in threshold voltage, and in reverse bias only a very small reverse saturation current flows until breakdown. So okay, so this diagram is not appropriate. Just I'm making the correct one. So in forward bias it should look like this. It will increases rapidly after some time, so it will look like this for forward bias. So this is the, as you can see, forward bias current increases slowly at first and then rises rapidly. So this is the diagram. So here this question paper ends, and let me just check if there is anyone. Yeah, so here this question paper ends, and in next class we will solve the next question paper from any other year, another PYQ. Okay.